So hello everyone. For today video, we have a question of designing a minimum stack. It's a medium question of lead code. So for the brute force, we can think that firstly the problem states that we have given a number of values that are pushing in our stack, and we have to return the minimum value that is present in our stack. So that's the problem statement. For this, uh, we have a brute force of we will be traversing again and again in the stack and finding the minimum value. So that's how we can solve, but it is not the optimal one, and our complexity will be reaches to big O of n square n cube depending upon the number of operations. So it's not a better solution. For a better solution, we can take a pair of set in our stack, in which our there will be two values storing. Our first value will be our the current value in our stack, and the second value of pair will be shows as our minimum value. So by putting the element firstly, let's take an example of pushing 12, 15 and 10 in this order. So firstly our stack is empty. We will be storing the 12 as the stack is empty. So 12 will be also our minimum value. So a pair will be put in our stack as current value is 12 and our small value is 12. So 12 to comma 12 will be put in our stack. Again, our next value comes as 15. So 15 will be our current value and small value will be as 12. So 15 comma 12 will be stored, and we moves in a stack, and at the end 10 will be stored. So 10 comma 10 means 10 is our current value and 10 is the smallest new value will be stored in our stack. So that's how we will able to put all the values, and after this we will be writing a cat min function, and we will be comparing the value of stack dot top dot second. If is so stack dot top dot second is our minimum value that we want, and stack dot top dot first is our current value that is on the top of our stack right now. So that's how we will able to write the code. So for the code, uh, we will make a stack of pair and simply check the condition if stack is empty. So simply put the new value as value comma value, or if stack is not empty, we will be comparing our we will be putting the stacks new value as well, while the minimum value will be shown as minimum of current value comma stack dot top dot second, means the value that is previously in our second pair element, is it smaller or our current value is smaller, whichever will be the smaller will be put in the current dot top dot second value. So that's how we will able to put all the values. After that we will write a getPin function where stack dot top dot second will be our new minimum value, and we will return that value. So that's how we can solve the question. For the complexity, our time complexity will be big O of 1, while space complexity reaches to big O of 2n, as we are storing a pair operation. So we are using n comma n means 2n space. So it is optimal solution, not the optimized best solution. For the best solution, we have to make sure that we will be using the extra space of big O of n only, not big O of 2n. So for the extra space, there is a concept and a mathematical expression. We will be using that. So let's take the same example, pushing off 12, 15 and 10 in our stack. So let's find out where we are getting stuck. So firstly we put the 10. Firstly we put the 12 value, and it's our minimum value. We will be storing in our minimum. Then 15, then 10. After this, 10 will be our new latest minimum value. After popping out 10, that is our top value of our stack, we will get back to 15. But 15, so 15 is not the small value, and 15 will be popped out after all, and then we will have to our minimum value as 12, but here we got stuck as in our initialized int value of x, that is our minimum value, is currently showing 10, but 10 is not in our stack and it's already popped out, so new minimum value should be 12, not 10. So this is the case, we are getting stuck. For this we will be using a mathematical expression that will be 2 into value minus previous minimum value, and that's our new value. So here we are modifying the value. It is only available if our new minimum is smaller, or maybe say that a new element that is coming in our stack is smaller than our current minimum. If it's the case, so we will be modifying that number. We cannot put directly that number because we are not able to reach back to that number. So for this we will be use 2 into value minus previous value, that's our new value. So for the 10, while pushing the 10 we will be not pushing the 10, instead we will be pushing 2 into well, that means 2 into 10 minus previous minimum, that will be our 12, as 12 is our previous minimum. So 2 into 10 minus 12 means we will be pushing 8 in our stack as the new value instead of 10. And whenever this case arises, we should remind in our mind that our new value or our minimum value is our stack's top value also. So minimum value will be 10, that will be updated, and our stack dot top value will be also 10, not 8. We have to remember this. So we will find out this edge case in further pseudocode discussion. And for the comparison, like if we want our previous value back, when we will be popping out 10 and we want our previous value as 12. So for this we will be modifying this formula, and we will be able to get back our previous minimum value as 2 into value and minus new value. So the new value, that is our 8, that's in our stack, that will be the new value. And 2 into value, here value is the current minimum value, that is 10. So 2 into 10 minus 8 equals to 12. That's how we will able to reach back to the previous minimum value which we were stuck in earlier. So that's how we will able to solve this. For validating is we can simply know that value, that's our current value, means 10 is the current value, is lesser than the minimum value, that is 12. If this is the case, only we are checking for this. So if a value is less than minimum value, so we will be taking value in our left hand side. So now the question is value minus minimum value is less than 0. Now editing val in both sides, we will get back 2 into value minus minimum value is less than the value, that will be the new value. So in our formula, that is also as similar as this, as 2 into value minus minimum value is nothing, it's just the previous minimum value. So that's how we are able to proving the mathematical expression. And now we will be discussing the pseudocode. So for the pseudocode, we will be making a class of minimum stack, and in this minimum stack we will be pushing the value. If our stack is empty, we will store the minimum as our current value and put the element in our stack. If it is not the case, means stack is not empty, stack has some element, then if we will have two cases. If our value that is coming is greater than the minimum value, if it is the case, so we will simply put it like there was a case where our minimum value was 12 and new element is 15. So we will not modify the 15 and simply put it in our stack. And if it is not the case, means new value should be modified, means the new value that is coming is less than our current new value of stack. So we will be what we will be doing, we will utilizing the formula of we will be pushing out 2 into well minus minimum, means we were storing 8, so that was our modified element, so that's come from 2 into well, 2 into current value that will be inserting in our element, we should insert that element, but we are modifying it, so 2 into well minus minimum means the minimum value that is that was previously in our stack, so we will be subtracting and storing this value, this new value will be stored, and our minimum will be updated with this value, and our minimum will be the minimum element and will also be the top element of our stack. It is basically we are putting 8, but reminding to our mind that 10 is our top element and 10 is our minimum element. So that's how we are able to do this. For the popping function, if stack is empty, we will simply return back. If it's not the case, then we will take an x value, and x will be our stack dot top value, and we will popping out stack dot top, and now we will compare if x, where x will be nothing but the 8, that is our modified value, so we will compare if our modified value is less than minimum, means the current minimum, if x is less than minimum, then we will be updating the minimum as 2 into minimum minus x, means for this that shows that if our minimum is 12 and we are on 15, so we are updating our minimum as 2 into minimum minus x, means 2 into minimum, that will be 12, minus x, x is our modified value, that is 8. So that's how we are able to get back to new value, to new minimum value. And for the top function, if stack is empty, we will return back the top function, and if it is not the case, then we will be storing x is equals to stack dot top, and again similarly comparing if minimum is less than x, so return x, means if our minimum, that is 12, is less than x, x is nothing but our stack dot top means 8, if our minimum is less than x, so we will be returning the x value. Let's analyze top, if stack dot empty, it will be okay. So if x is stack dot top, means our value, that is minimum value in our stack, if it is the case, so our current minimum value is greater than our x, so we are because x is modified version, so we are returning the x value, else if we will be simply return the minimum value. So it's still confusing because the question is depending upon a formula for the optimized approach. So here the complexity, for time complexity it is big O of 1, and for the space complexity it is big O of n. So that's how we will able to solve this problem. And for today, that's it. We will be adding in new video. Till then, keep updating, be consistent.